Hello everyone, I'm Sangeetha and I'm here to give a presentation on asynchronous data transfer in computer organization and architecture. As you all know, computer organization and architecture is one of the core subjects of CNC, CSE and its child branches. Now, in most of the competitive exams, you get questions from computer organization and architecture. In that, asynchronous data transfer is one of the important topics. So let's discuss that asynchronous data transfer. Now, before going to what do you mean by asynchronous data transfer, let's understand what do you mean by data transfer. Data transfer is nothing but when you are moving data from one place to another place without any manipulations. It is called as data transfer. Now, when I'm saying moving data, it can be either from registers to memory or from memories to accumulator, accumulator to register, any other register, and so on. That transfer of data from from one place to another place is called data transfer. Now, there are two types of transfers in this: synchronous transfer and asynchronous transfer. Now, what do you mean by synchronous transfer? Synchronous transfer is when the two entities in which the data is being transferred are synced or aligned with each other. That is, they know when the source is sending the data and when the destination is receiving the data. When this is aligned, it is called as synchronous data transfer. Now, what do you mean by asynchronous data transfer and where it occurs? Now, asynchronous transfer is nothing but when the two entities in which the data is being transferred are not aligned or are not synchronized with a clock pulse, then it is called as asynchronous data transfer. Now, the internal operation in an individual unit of a digital system are synchronized using clock pulse. That is, all these components are synchronized. That means whenever we are transferring the data and when the destination is receiving data, it's all aligned with the clock pulse. Now, suppose we are transferring the data between a faster system and a slower system. At that time, you cannot expect, for example, memory is comparatively faster when compared to processor. So now, when memory is transferring the data, it will transfer the data at a slow rate, whereas the processing of data in the processor is a very, very fast rate. By the time memory sends 10 or 10 bits of data, in that time, the processor might have processed 100 bits of data. So because of the speed difference and the timing difference, the processor has to keep on waiting to get the data from the memory. So instead of waiting for a longer period of time, what happens is the memory should take the initiation of transferring the data as well as inform the processor that it is transferring the data. The processor, when it receives the signal from the memory, it will attend the data and perform the processing on the data and then transfer the result back into the memory. Now what happens? If the registers in the I/O system interface share a common clock with the CPU registers, then transfer between the two units is called as synchronous. But in most of the private clock offer for its internal registers, in this case, two units are said to be synchronous to each other. And if the data transfer occurs between them, then this transfer of data is called asynchronous data. That means when the two units in between which the data is being transferred, they are not aligned with the clock pulse and then they are transferring the data, it is called as asynchronous data transfer. Now, but there should be some way in which the transfer of the data between the two units can be controlled. So with the help of some control signals, which are transmitted between the two units, we indicate the sending of the data as well as of the receiving of the data. These two methods achieve the asynchronous way of data transfer. Got it? Now, the two methods in which these control signals can be initiated from the source or the destination are either it is a stroke control method or a handshaking method. Now, what do you mean by each? We'll see now. The stroke pulse is supplied by one unit to indicate that the other unit when the transfer has to occur. That means what? Now, the stroke pulse is nothing but a control signal. So when one of the units is starting a control signal to tell the other unit that the transfer is about to begin or the transfer of data is about to start, then it is called as the stroke control method. Now, the second method is handshaking method. This method is commonly used to accompany each data item being transferred with a control signal that indicates data in the bus. The unit receiving the data item responds with another signal to acknowledge the received data. Now, understand this class. In asynchronous data handshaking method, what happens is here two signals are being transferred, where the first signal is transferred by the one unit, which will tell that the transfer is up, it has been started. The second control signal is initiated by the other unit. This is like to acknowledge. This is like giving a response to the source saying that, okay, whatever the signal and data you have sent, I have received that. This is one of the major differences between stroke control method and handshaking method. The stroke control method is a one-way communication where any one of the unit will initiate the control signal and the other unit will respond. The handshaking method is a two-way communication method where one of the unit will start the communication along with the control signal and the other unit will acknowledge it by giving a control signal about the receiving of the information. Now, why I'm telling units over here? Because both either the stroke control method or the handshaking method can be either source initiated or destination initiated. Now, what do you mean by this? Source initiated means when the source is starting the stroke signal, that type of communication becomes stroke communication, stroke initiated. When the destination is starting the control signal, that type of communication becomes destination initiated signals. Now, in both of them, we are having both source initiated transfers and destination initiated transfers. Now, both the stroke pulse and the handshaking methods of the asynchronous data transfer is not restricted to IO transfer. They are used extensively on numerous occasions requiring the transfer of data between the two independent units. So we have to consider the transmitting unit as the source and the receiving unit as a destination. The two units which are involved in the communication, one will become the source who is transferring the data, and one will become the destination who is receiving the data. Got it? Now, for example, let's take an example over here. Suppose there is CPU, and one of the units, let's say memory is the destination unit. So when CPU is the source during the output and write of transfer, and destination unit during the input and the read transfer. Whenever we are writing the data, that is whenever we are storing the data into the memory, CPU is the source one and the memory is the destination one. Whenever we are reading data from the memory, CPU becomes the destination unit and the memory becomes the source unit. The roles are interchanged based on the direction in which the data is being transferred. Therefore, the control sequence during asynchronous transfer depends whether the transfer is initiated by the source. That's what I just said now. That is, if it is source initiated, then when the control signals are initiated by the source, it becomes source initiated. When the control signals are initiated by the destination, it becomes destination initiated transfer. So while we are discussing each of the transfer method, let's see the control sequence in both the terms when it is initiated by the source and the transfer. Okay. Let's see the two types of communication using strobe signal. That is, let's see what is strobe initiated transfer, source initiated strobe transfer, and what do you mean by destination initiated transfer. Now see here, in this block diagram, what you can see is there is one source unit, one destination unit. There are two lines. One is representing the data bus, another one is representing the strobe signal, that is the control signal. So now here what happens is whenever this source wants to transfer the data to the destination unit, it will first initiate that source signal, which will reach the destination, indicating that the source wants to transfer. Now, after some time of initiation of strobe signal, the source unit will put the data into the data bus and will transfer the data. See, if you see the timing diagram over here, There are two types, two signals. One is data and one is strobe. When the strobe signal is first activated, this upper line means activation. Down line means it is in the deactive mode. When the strobe is in the activation signal, strobe is activating it. So first strobe signal is activated, then the data is put on the data bus, which remain and strobe signal remains on or active for a period of time, some period of time, say for some amount of time. During that, whatever the data transfer is done between the source and the destination, that is a valid data. Got it? Now, another method of strobe signal transfer is destination initiated strobe. Now, in this, what happens is the destination unit will receive the data from the source and then initiate a control signal indicating to the source that whatever the data you have transferred has been received successfully by me. See, if you see here, there is one source unit, one destination unit. There are two types of buses. One is the data bus and one is the strobe signal. So when the source first, it will start transferring the data. After receiving some amount of data, the destination unit will have to send a strobe signal. This is to indicate or give information to the source that valid data has been received by the destination. So see, if you see the timing diagram here also, first the data line gets activated, indicating that the data is being transferred from the source to the destination. After some time, the strobe signal, after some time, the strobe signal gets activated, indicating that whatever the data is there in the database is a valid data. Then the strobe signal gets deactivated and automatically the valid data, that is the data line, gets deactivated. Understand one thing, class, over here, whether it is strobe initiated or destination initiated or source initiated, in either of the ways, the data will be sent from the source to the destination only. Now coming to the second one, the second method of asynchronous data transfer is using handshaking method. Now, asynchronous data transfer using handshaking method is like a two-way communication where the source will send the data and the destination will also acknowledge the reception of the data. Now, why do we need to have a handshaking method when we are already having a strobe method? So the basic disadvantage of the strobe method is that the source unit that initiates the transfer has no way of knowing whether the destination has received the data then which is placed on the bus. That is, we do not have any information that whatever the data the source is sending is actually being received by a destination or it is being lost. So now, similarly, a destination unit that initiates the transfer has no way of knowing whether the source unit has placed the data on the bus. That is, it's both the way we are not able to know whether it is being initiated by the destination or it is being initiated by the source. In either of the ways, we are not getting to know whether the other party is actually receiving the data or is actually placing the data or not. To overcome this problem, we use handshaking method. As I told you, there are two signals over here. The first signal will tell you or indicate the data transfer, that it has been started, and the second signal will indicate the reception of data by the destination unit. There is one control line is in the same direction as the data flow in the bus from the source to the destination. The source unit uses it to inform the destination unit whether there are valid data in the bus. The other control line is in the other direction from the destination to the source. This is because the destination unit uses it to inform to the source whether it can accept the data in it. Also, the sequence of control depends upon the unit that initiates the transfer. So it means that the sequence of control depends on whether the transfer is initiated by the source or the destination. Got it? I think it will be easy for you all to understand if you look at this diagram. Here also, like in strobe, how you had two types of transfers. One is source initiated and one is destination initiated. Here also you have two types of transfers. One is source initiated handshaking, and one is destination initiated handshaking. Now what happens here in the hash? There are two types of control signals. One is data valid signal and one is data accepted signal. The data valid signal will indicate whether the data on the data bus is a valid data or not. This control signal is generally initiated by the source unit because it is a source initiated transfer. And this data accepted line is indicate that whether the data has been successfully accepted by the destination unit or not. It is generally generated by the destination unit. See, look at the diagram over here. There's one source unit and one destination unit. This source unit will first place the data on the data bus. After placing the data on the data bus, it will activate the data valid line. The use of this data valid line is that it is to tell whether proper data has been placed on the data bus or not. After the data has been placed on the data bus, then after some time, the destination will initiate one of the control signals, which is called as a data accepted signal. This is to indicate the source that whatever the data was placed in the data bus by him or her has been accepted by the destination unit. See the timing diagram signal. There is one data bus, one data valid line, and one data accepted line. Whatever the data whenever you're placing the data into the data bus, it gets activated. The signal goes up. After placing the data, after some time, the source will start the data valid line signal. This is to indicate that whatever the data is there in the data bus, it is a valid data. After that, after some time, once the data has been received by the destination will initiate a data accepted line. This is to inform the source that the data has been accepted. Then, eventually, after a period of time, the data bus gets deactivated. Then the data valid gets deactivated. And then lastly, the data accepted line also gets deactivated. This is the series of actions which takes place once right from the placing of the data onto the data bus until the acknowledgement is being received from the destination. See here. First, what you do is place the data on source unit does two tasks. It places the data on the data bus, enables the data valid line. After that, the destination unit, when it receives the data, it is ready to accept the data from the bus, enable the data accepted line, which then disable after some time. It will disable the data valid line and invalidate after the disabling of the data valid. Once this data valid line gets deactivated, whatever the data you send on the data bus gets invalid. Now it is no more valid and the entire data is invalid. Once this has been done, then we disable the data accepted line. And that means when we are disabling the data accepted line, it also indicates that now the destination is ready to accept new information. Whatever the new information you want to send, that is ready to get accepted by the destination unit. Got it? Now, second type of transfer is destination initiated handshaking. What happens in this is also a two-way communication. We have two control lines. One is the data valid line and ready for data. Now the data accepted line is no more there. We have only a new line called ready for data line. This is generated by the destination unit. The entire communication process or the transfer process between the two units is now initiated by the destination. That is why we have a special line called ready for data line. Only the name has been changed, whereas the entire meaning remains the same. So destination initiated transfer means obviously the transfer of data and the communication should start from the destination. So likewise, see here, there is one source unit and one destination unit. The source unit is responsible for sending the data onto the data bus, which is accepted by the destination unit. The destination unit is responsible to accept the data, is responsible to receive all the data from the, is ready to accept data from the source unit. So now see what happens is, first the destination will send one signal. That signal is nothing but ready for data signal. This is to indicate the source unit that now the destination is ready to accept any new information or any new data from the source unit. Once this gets activated and this signal reaches the source unit, now the source unit will place the data onto the data bus and will activate the data valid line. See here, first the data ready for data gets activated. After that, the data bus places data is placed on the data bus. That is why this gets activated. After that, the source will initiate a signal, which is called the data valid signal. Now, till the time the data valid signal is ready or is active, the data on the data bus is valid. After some time, the ready for data bus gets deactivated, indicating that the destination is not ready, has received the data and is not ready for any other new information. Then the data bus gets deactivated, indicating that there is no more valid data on the data bus. And then at last, the data valid line gets deactivated, indicating that there is no valid data onto the data bus. But it understand, let's see the block diagram over here. There is one source unit and one destination unit. The source unit destination unit will first send a signal telling that it is ready to accept the data. Once the signal is received by the source will place the data on the data bus and will activate the data valid line. Once the signal is received by the destination will deactivate the ready for data line and which is to indicate that now the data has been successfully received by the destination. This is how the transfer of data in the asynchronous mode occurs between the two units, that is the source and the destination. Okay. Basically, there are 4 types of transfers: 2 for strobe signals and 2 for handshaking method. The two methods for strobe signal is that source initiated transfer, destination initiated transfer. This 2 for handshaking method is source initiated handshaking and destination initiated handshaking. This is all about the asynchronous data transfer. Now let's see the advantages of asynchronous transfer and disadvantages of asynchronous transfer. Now, there are various advantages which the asynchronous data transfer is that it is more flexible and the devices can exchange information at their own pace. Now, what happens is when we are going for synchronous transfer, we should ensure that the two entities which are involved in the transfer are synchronized with each other. But this is not the problem with asynchronous transfer. Whether the speed of the two systems are same or not, whether the clock cycle is synchronized or not, irrespective of that, the two entities can transfer the data. Here, apart from transferring the data on their own pace, individual data characters can complete themselves so that even if one packet is corrupted, its predecessors and successors will not be affected. That is because it is asynchronous data transfer. Suppose if one is the invalid data, rest of the data can continue with it. But that is not the case with synchronous data transfer. If one data packet is invalid, the entire transfer of data gets corrupted. Whereas here, irrespective of one packet is corrupted or not, the rest of the packets can continue their transfers. Moreover, the third advantage of using asynchronous data transfer is that the complex processes by the receiving device, it does not require that complex process. That is, we do not have to synchronize it. We do not have to see to it whether they are properly accepting the data or not. Whatever the inconsistency of the data transfer is there, it does not result into a big crisis. Since the device can keep the data in the data stream, it also makes asynchronous suitable for applications where the character data is generated irregularly. This is one of the few of the advantages. Now coming to the disadvantages. Disadvantages data transfer is nothing. Asynchronous data the disadvantages of asynchronous data transfer is that Now, the success of these transmissions depends upon the start bits and their recognition. This can be susceptible if the line of interference causing these bits to be corrupted or disordered. Suppose we are not able to distinctly tell about the start bit and the stop bit, then what happens is we are not knowing when the data is started, when the actual data has been started, and when the corrupted data is there. This is one of the major disadvantages of asynchronous data transfer. And the second disadvantage of asynchronous data transfer is that when the large portion of the transmitted data is used to control the identity header bits and thus carries no helpful information related to the transmitted data. This means that the more data packets not to be sent. That means we cannot transfer large amount of data in asynchronous data transfer. Let me just summarize this. This is all about asynchronous data. Let's quickly summarize what we have done on what we have studied in this class. First is asynchronous data transfer. That means when the two entities which are involved in the transfer of data from the source to the destination, when they are not synchronized by any clock pulse or anything, then it is called as asynchronous data transfer. Basically, there are two methods of asynchronous data transfer. That is the strobe method and the handshaking method. The strobe method means where one control signal is transferred from the source to the destination or from the destination to the source to indicate that the data has been valid data has been placed on the data bus. Strobe can be of two methods. Either it can be source initiated or destination initiated. Now coming to the handshaking method. Handshaking means when we are having two-way communication of the control signals from the destination or from the source in such a way that each of the entity can inform the other unit about the placing of the data or about the receiving of the data, then it is called as handshaking method. That is, it's a two-way communication. Okay. Again, in asynchronous data transfer, we have two methods: source-initiated handshaking and destination-initiated handshaking. In handshaking, basically, whether it might be a source-initiated or destination-initiated, there are two types of signals. One is the data valid signal to indicate whether the data has been properly placed on the bus or not. And one is the data accepted signal, which is initiated by the destination to inform the source that the data has been successfully accepted by the destination unit. If it is a destination initiated handshaking, then first the destination will inform the source that it is ready to accept any new kind of data or information. After receiving that signal, the source will transfer the data. After transferring the data, it will initiate a valid signal indicating that whatever the data is there on the data bus is a valid data. This informs the destination that whatever the data is there, it has been transferred by the source and is a valid data. As you all know, the asynchronous data transfers are easy to initiate because you can have any devices. Even if the pace of the devices are not matching, the speed of the devices are not matching, still the transfer can take place because it is asynchronous and which can be controlled by any control signals. This is one of the biggest advantage of having asynchronous transfer. Coming to the disadvantages, in asynchronous data transfer, the biggest disadvantage is that you cannot send a large amount of data without having a proper start bit and a stop bit. It is very important you are to distinguish between the start bit and the stop bit so that it can properly define from where the actually valid data is starting and where the valid data is ending. This is all about asynchronous data transfer, where the transfers, where the transfer of the data takes place between the two entities. Thank you, class.